As we've been focused on lists, we've learned a number of common operations such as append or pop to remove an item, but we haven't looked at how do you actually change items once they're established in a list? How do you reassign a value at some index to be a new value? This is a common thing that we'll do when we're working with lists and we're okay with mutating list information. One example is if you had a to-do list and you wanted to reorder the arrangement such that something that you just added to the list is now at the very top of your list, you would need to be changing the values at these indices, right? Because your index 0 is always the first item. So how can we actually change the items stored at our indices? Well, in this handwritten memory diagram example, I'm going to ask you to try pausing and following along in just a moment. But let me talk through just the very first example and then turn it over to you to try carrying out the second two. So notice we are starting with this list 0, 200, 300. We've established that in our heap ID 0, and that's being assigned to x's, and x's in globals is this ID 0. And here we reach our very first assignment statement. Here we're saying take the value on the right-hand side of this assignment operator, 100, and that's fully evaluated, nothing more for us to do here, and assign it to x's index 0. Now here's where things are interesting. Notice this is a little bit different than what we've seen with just a plain variable assignment. Here we're needing to dereference x's. In other words, if we think of x's as ID 0, we need to go look up what is index 0 of ID 0 and where does that refer to in memory. Well, ID 0, of course, is this location here. And then index 0 is referring to this value right here. So this is the position in memory that we're trying to update to be the value 100. So the way we'd annotate our list here is just say, this is 100. And if we write this value outside the box, that's okay. We know that this new value at index 0 was assigned 100. And that's how you would think about continuing on with this first statement. I'm going to turn it to you to try carrying out the second the next sequence of steps. And so try pausing the video here and seeing if you can get it. All right, so on the next line, we have a variable assignment. So I is initially 1. And then we reach a more compound or complex, I should say, assignment expression where we are accessing an item in the list, adding some value to it, and then taking that new value that we've just calculated and reassigning it back to some location in this list. So let's follow this out slowly, and I'm going to use green to indicate what our steps are. So first thing we got to do is evaluate what is I. We look in our current frame, I is 1. So this simplifies to x's index I 1 plus 50. And again, if we look at what is x's index 1, if we wanted to be very pedantic here, we could say, okay, we know we're talking about ID 0 on the heap, index 1. So index 1 of ID 0 is a value of 200, plus 50, of course, is 250. So this whole expression here evaluates to 250. So I'm going to go ahead and sort of delete this to get rid of it or erase it. And now what we're saying is this is what that right-hand side of our expression evaluated to. So now we need to finish out this left-hand side. And here's where it turns out we can have an expression on the left-hand side of assignment, specifically here, right? So how do we think about this? Well, I is 1 in our current frame. So this is saying x's at index 1 is going to be assigned 250. Well, x's index 1, again, if we want to be pedantic, x's is ID 0 on the heap. 1 is 250. So when we go to figure out what is ID 0, well, of course, that's this location here. This is our list. What is index 1 of that list? That's this location here. And what we're trying to say is update this value to be this new value we're assigning to it. So we are going to replace 200 with 250. Cool. And then this last expression here, or this last assignment statement, I should say, again, always start on the right-hand side, and let's simplify that first. So we look up I is 1, 1 minus 1 is 0. So we're saying x is at index 0. Again, to be very pedantic, x's is the heap object with ID 0, and that's going to simplify to this. So what we're talking about here is we go and we look this value up, and we see, okay, ID 0, index 0. Well, we just replace that. That value is 100, right? So this would simplify to 100. And I'm going to go ahead and just clear this out and give myself some more space here. So now we're looking at x's of I plus 1. And let's simplify the right-hand side. So I is currently 1, and 1 plus 1 is 2. So x is 2 is assigned 100. Well, this is ID. We already know this is ID 0. We know that we're talking about this particular location right here, right? So this is going to be updated to be 100. And while thinking through these steps in a very mechanical way can oftentimes feel like complex or feels like it's hard to follow with what's going on, it's important to realize that we can think a little bit at a slightly higher level of abstraction. And on a line like this, if we're talking about, whenever you're talking about an index like I, if I is 1, that means we're talking about, relative to this particular index, this is saying, look at the index before me, which was 100, and assign that value to the index that's after me. So we're saying, okay, 100 is being assigned to index 2, right? So this is saying, if we're currently focused on the index I of 1, assign to the index right after me, whatever the value currently stored at the index before me is. And this type of a trick we'll see is commonly used in many algorithms that involve lists. So this is how we can assign values to items in a list using the assignment operator. And know that we have to do a little bit of work, but we have this creative potential to put expressions on the left-hand side of our assignment operator such that we can target indices relative to where we currently are and assign values in that way. This is very handy in things like reordering a list or sorting a list and other algorithms we'll see using lists in the future.